Welcome, y'all, back to some more algebra. Today we are talking about functions and graphs. So let's kind of look at this right here. So let's see, functions again are a set of values. In this case, with the first set we call the domain. To a second set we call a range. Now their I guess relationship to each other will determine if things are functions or not. So when you're given a one set thing and you're comparing to a second set thing, we're talking about domain and range, as we'll talk about here. We usually call this our x's right here. So sometimes we call our domain our x's and our ranges our y's in this case. But in this case, so this is these names right here. These are our x's and these are our y's. We're going to determine in a graphical way, are they a function or not? So functions, in this case, everything from here should only go to one other thing over here. So all x's should have no more than one y for it to be considered a function. So for example, James Franco here, he was in this movie. Dwayne Johnson, Tiffany Haddish, Robert Downey Jr. So all these right here, so this set right here is a function. It's good. Everything here goes to one thing only. Now, can everything go to one? That's fine. So let's say like all these were in the same movie. Let's say every single one of these were in this movie, just this movie only. So let me clear that off here. Let's say they all were in night school right here. That is fine because everything over here is going to only to just one unique thing. Here is where we run into a problem. So James Franco's here. He was in the interview. Dwayne Johnson was in Jumanji. Tiffany Haddish was in Nothing. Robert Downey Jr. was both in Iron Man and Tropic Thunder. Here's where the issue happens. This way you know if it's on function or not. Because the value of our x, or in this case, our left side, did split into two different things. This happened right here. This would be not a function. So as you're given a set of numbers, as we're about to do right here, you're going to determine if this relation of domain to range is a function, yes or no. Okay, so like we said, our domain here, so our domain will be our 9. You only write one of these. So there's two 9s right here, so we're going to write 9 once, 9 and 2, our x values. Our range will be our -5, 5, and 4. So let's see, like we said, what's the relation? Well, 9 has a relation with -5, so it has a relation with -5, but 9 also has a relationship with 5, and then 2 with 4. Because the value of this 9 has two different functions right here, or relation to two different things, then this is not a function, Now, I have my domain, I have my range. Let's look at this again. Let's try this one right here. So, domain, we have -2, 5, 0, and 4. Range, which is just our y values, be 5, 7, 1, and -2. So let's see. 2 goes to 5, 5 goes to 7, 0 goes to 1, 4 goes to -2. There's no other things matching up. So yes, is a function. So as you go ahead and pause this and then try this one out. See if we get the same answer. So we have -5. So domains is -5, 0, and 6. Range is 3, 3, and 3. They all, and again, it should actually be, I did that wrong. It should be just 1, 3. All these go to it. Since all those are going to it, then we're good. Each one of these only goes to one thing. They're not splitting it off like up here. So this again, even though they all go to the same 1, 3, it is still a function in that case right here. So let's kind of look at the notations, I said, of full functions, notations of these functions right here. How we see some of these functions. So functions of the math can be given in equation form. Y equals x squared minus 9x minus 12. We've seen this already in our linear equations. Linear equations in the form of y equals mx plus b. This is a function on its own. But the input, the things you put in for x, is your domain. The output in this case, what's the final answer for y? Those are our range. So understand, we talked about this before. Our domains are also our independent variable or letter, independent letter. And these are dependent variable. So if we call this a function, then we use x to represent any possible value that we put in. F of x, this f parentheses x, also the way we read it is f of x, or the value of f at x. Those are our y values. So you'll see this happen. They'll change this y to f of x. That's saying the function f of x, or the function according to x. What will be the value of this function when x is 0, -7, 5a, or a minus 4? That's part of it right here. So to figure that out, all we're going to do is substitute these values in. So we'll start at f of 0. So we're going to put in a 0 in for, if they give you f of 0, that means wherever there's an x, you're going to put a 0 value there. So 2 parentheses 0 square minus 0 plus 3. So that goes away, leaving me 3. So f of 0 equals, so f of 0 has a final value of 3. So when x is 0, y is 3. So you can write this as a coordinate form as well, 0, 3. Let's try it with the -7. So you guys go ahead and pause and try these other 3, and then we'll compare answers. So, all right, so on here, you should have done f of x equals 2 parentheses -7 squared. Actually, I'm going to write it properly. There we go. Parentheses squared minus -7 plus 3. So -7 squared becomes a positive 49. So then it'll be 2 times 49 minus a -7, which becomes positive 7 plus 3. So 49 times 2 will be 98 plus 7 plus 3. That gives us 108. So f of -7, so the value of the function according to -7 is 108. All right, so on 5a, you plug that in there. Let me change the colors. We'll have something like this. It'll be 2 parentheses 5a, that's squared, minus 5a plus 3. So we square the 5a, we get 25a squared, and then that's times 2 minus 5a plus 3. Now, here's the thing. This will change, so we'll end up getting 50a squared, but that's it. So it'll be 50a squared minus 5a plus 3. You can't do anything else. So f of 5a equals this. So you'll get some answers where it'll give you just an equation out of it. That's fine. That's a perfectly acceptable answer. Let's try that one more time. On this next one, I'm going to make some room. So I'm going to erase this. Hopefully you did it all, got it down. Make some room for myself. Do this in pink. All right, we're going to do this problem up here. So this time, same thing. We're going to keep substituting, and we're going to substitute a minus 4 into the problem this time. So it'll be 2, and then be parentheses. Oh, what a pink. What a pink. There we go. Let's go with this hot pink right here. All right. It'll be 2 parentheses a minus 4 squared minus a minus 4 plus 3. Start with this. So a minus 4 squared means a minus 4 times a minus 4. So you'll, as you like to call it, FOIL that out. You ultimately end up getting, the 2 still on the outside. You'll get a squared minus 8a plus 16 when you do that. And then since we have this negative outside the parentheses, we're going to distribute this negative to both things on here. So we end up having minus a plus 4. It changes that negative 4 to a positive 4. And we got this plus 3. And we'll combine things in a bit. Now we got this 2 in front of this equation right here. So we're going to distribute that 2. So everything on here, we end up getting 2a squared minus 16a plus 32. And then we keep everything else, minus a plus. I'm going to go ahead and combine these two, plus 7. So we're going to go through now and combine like terms. So I can combine this and this together. And then this a, this negative a, I can subtract it over here. So we're left with the final answer of 2a squared. Then negative 16 minus a is negative 17a. And 32 plus 7 equals 39. And that's your final answer right there. So as you get through problems where they give you something like this, all you do is just substitute those values in there and give me. Some of the times they'll give you a final answer like these 2 did. Sometimes you'll get equations with that. That's perfectly okay. Let's look at this next one right here. Now, we need to graph the function. We're not going to graph the function. I guess we could, sort of. So we talked about x squared. It's a last problem, but it's -5. So it starts right here. 1, 2, 3, 4, 5. So your graphic calculator, this would be perfect. You can plug these in. And this one looks something like that. Ooh, that's a horrible other side. It's crazy. Being left-handed, I can draw to the left, but to the right, not so much. Weird. All right. So like we said, domain and range also means, hey, how far, what way are the x's and the y's going on a graph? So when we're looking at this graph, we could say, let me get right here. We're going to switch it to this right here. We have a domain and our range. Now, again, domain on the graph is x value. So how far to the left and how far to the right did this graph ultimately go? So understand, these arrows at the end of this is going forever this way. So as it's forever going up, it's also forever going to the right. And as it's forever going up on this side, it's forever going to the left. That means ultimately the domain of this is going to negative infinity and then also positive infinity. So in this case, it has a domain of negative infinity to positive infinity. Now, we started working with these right here back in chapter 1, where we're setting these up right here as far as certain values in there. Remember, and it's just on a number line. Same thing here. These are our number lines, our x-axis and our y-axis. What is this graph doing? Is this stopping at a certain point? Is it only going so far up, so far down? In this case, since it's going forever up, it's also going forever to the left, forever to the right. So that means left to right, our domain goes from negative infinity to positive infinity. Let's look at our range. Our range is up and down. What is the lowest value here? What's the lowest possible value we'll have? This down here, that -5. Now, it does include the -5, so we put a bracket around that. What is the highest value this has? It goes forever up. So that's our positive infinity. So that's how we figured domain and range on these right here. Domain and range. All right, I'm going to erase this and then kind of look at the other one. If you put this on a graphing calculator, I mean, if you don't have one, you go to desmos.com, desmos.com. It's a free online graphing calculator. You literally plug in the question like that. I think you can do it from your phone as well. And they might have an app. You can plug this in from your phone and it'll graph it for you. So as you do this, it actually starts right here at a 1, 2, 3, 4 right here. And this equation looks like this. A lot curvier and not so like crooked. Sorry. Kind of seemed like I had Tourette's through the whole thing. Let me see if I can do a better one. Let me clear this off a little bit. It's kind of bugging me. I don't know why. I'm not much of an OCD person, but that does seem a little annoying. 1, 2, 3, 4. There you go. That's a little bit better. All right. So this is how somewhat the graph of this looks like right here. So we're going to do the same thing. We're going to talk about domain and range. So again, domain. What is the furthest left value this has? The furthest left, or the furthest negative value ever it has, the furthest left value is this one right here at that -4. So it has a domain. Smallest value possible is -4. What's the highest value to the right? See this arrow? It's going forever to the right. So it has a positive infinity. Yeah. Range. What's the lowest value this has? Well, the lowest value is right here on the line itself. So that's a value of 0. What's the highest value? So it's going forever to the left, but it's also kind of going up slightly, but it's going up forever. So that goes to a positive infinity right there. All right, and that's how you determine your domain and range graph-wise. We'll continue for here on the next section. Y'all, we're going to split this in 2 parts. But other than that, have a great rest of your day.